Hey everyone, welcome to Chippy, or the Chicago Python User Group. Today is our Dunder main meeting, which is held on the second Thursday of every month. My name is Joe Jasinski. I will be the MC for today, and I'm one of the Chippy organizers. Before we get started, I'd like to just talk about our code of conduct real briefly. Code of conduct is how we expect people to engage with each other online and in-person meetings. So please check that out on our website and abide by it. Basically, it boils down to please respect each other. So what is Chippy? Chippy, or the Chicago Python User Group, is a community-focused organization supporting the Python programming language in the Chicago area. We've been around since 2003, and we've been slowly growing. So from a small group that would meet in the back of a bar or in the small startup space, and to one of the largest Python communities in the world. We have thousands of people in our various online forums and hold a number of different events each month. So Chippy is made possible by all of the volunteers and organizers who give up their time to support Python in the Chicago area. Some of those volunteers are the board members recently elected, and we have a new board with lots of enthusiasm. So I'm really excited to get to know them better. And we have a ton of organizers who help with lots of different aspects of Chippy. So a big thank you to everyone who helps out. So we have a few Chippy initiatives. One is the Python Project Night. And that's a space where we meet together and work on common projects, like our own personal projects or as in group projects. It's all up to you, kind of to determine what you want to work on. There's the Buddy Mentorship program. If you're looking for a mentor or want to mentor someone, then we have a website and an app to help connect you with pair up mentors and mentees together. So check that out. Also, we have a Python lunch break, which is basically Chippy at lunch. So if you want to have a different, accommodate, or if we want to accommodate a different schedule, maybe people have their lunches free, please check that out. Here's another link to our Chippy mentorship program. It's at chippymentor.org. We also have a job board at chippy.org/job-board. So if you're looking for a job or want to post a job, check out our job board. We have a number of special interest groups which let us dive deeper into various aspects of Python. So we have a finance SIG, a data SIG, a web dev DevOps SIG, and an algorithm SIG. So if you want to get to know people and listen to talks about subjects in a little bit more depth, a little bit more specific, check out our different SIG meetups. Speaking of which, we have a few upcoming meetups. We have the Python Project Night coming next Thursday, April 15th. Then on May 6th, we have a meeting of the algorithm SIG, and the next meeting of the main meeting is May 13th. There's some Python news, or just general news in the Python community. Python 3.10 gets a case statement. That's really exciting. And it's more than just a simple select case statement. It lets you match on like different types of objects and such, or primitives. It's really more of an advanced case statement like you see in some languages like Scala and such. Pretty cool stuff. Check out the PEP, and you can really see what kind of powers you can gain by using the case statement. Cryptography.io started using Rust for their C compiled code. Cryptography.io is a Python package that is a very popular and very stable and secure for using cryptographic functions in Python code. And they chose to go with Rust for these more recent releases to take advantage of Rust's really like safe typing and ownership concepts. So I just thought that was kind of neat. And also, Python is 30 years old. That's pretty incredible to see that Python's been going for 30 years. And I hope for another 30 years and beyond for Python. So tonight's schedule, we have some great talks coming up. I'm really excited to hear them. There's Getting Up to Speed with Dask by Aaron Richter, and The Dangers of the Python Standard Library by Andrew Scott. So we'll bring those people very shortly and hear some great talks. During the stream on YouTube, you can comment in the comment box. So if you have questions for the speakers, please feel free to speak up, or if you want to say hi to other Chipy members or participate, feel free to do so. Please keep in mind our code of conduct. Really, just keep in mind that there's like a little bit of delay between the stream and when you ask a question. So please ask your questions a little bit before the talks end. So to get discussion started in our YouTube chat box, what Python news have you heard of? So I just mentioned a few pieces of news, Python news, but I'm curious to hear what other people have heard heard as latest news in the Python community. So it's always interesting to see what's coming up. After tonight's meetup, we have a hangout at chippy.town. Chippy.town is a 2D like virtual space where we can all kind of have a hangout, and if you don't want the party to end and want to meet your friends from Chippy and ask questions of people who are part of Chippy, check us out at chippy.town. I'll post this link again at the end of the talks. Hope to see you there. If you want to engage with the Chippy community, we have a Slack channel at Join Chippy Slack at herokuapp.com. So there's lots of different discussions that happen on Slack, different channels for different topics. So check us out there. We have a Twitter account, so you can follow us on Twitter for more news and information. And if you don't remember anything I just said in this talk, just check out our website at chippy.org. It's a jumping off point for all of our resources. Recently, the Web Guild has put a lot of great work into making it bigger and better than it's ever been. So have a look at that. Also, we have a raffle. Our sponsor, JFrog, has a monthly raffle with Chippy for Circuit Python compatible Adafruit Q with Bluetooth and one of 5 JFrog t-shirts. So you can scan the QR code or enter or click on the link that I send in the chat, and the winner will be selected in 2 business days, and the winner will be shared on our meetup page and congratulated on social media. So I'll post this again, but thank you to our sponsor, JFrog, for all the support they've given us. So let's get started with tonight's schedule. Let me bring our first speaker onto the stream. So I am going to bring Aaron Richter onto the screen. Hey, welcome.
Thank you. Thanks for having me.
Thanks for joining us. So tell us a little bit about yourself.
Yeah, sure. I mean, so I'm a data scientist. I'm based in South Florida right now, and kind of got into programming more around app development. Kind of in grad school, I kind of fell into data science, and then doing a lot of work in Python, obviously along the way. So I've done a lot of kind of like big data stuff, more like a lot of Spark, like Hadoop things. And then I've kind of recently done a lot more in kind of the data science and machine learning space, specifically in Python. And kind of that's where Dask comes in, as we'll see. So I'm, super excited to chat about all this stuff.
Cool. Yeah, I'm really excited about Dask. I've wanted to use it, and I'm excited to hear about your experience with it.
Yeah.
So besides Python, what's your favorite programming language? Even though I know Python's a far first, I hope.
Yeah. I guess being a data scientist, the second would be R, I think. It depends if you define SQL as a real language, right? Quote, real language. I don't mean that in an offensive, but I mean, like, it's probably a close tie between SQL and R, but I do like R a lot for their visualization capabilities, and RStudio is a pretty nice ecosystem.
Yeah, cool. Obviously it's been kind of a rough year with COVID and such. How have you been managing to kind of deal with that or stay sane and active?
Yeah, I mean, for me, actually, it's the active part, like going outside and doing things. I think I've done a lot more exercise over this past year than I had in the past. Maybe also a little bit of time left in the day that you don't have from commuting. So that's kind of the way that I've been kind of trying to at least help with my mental state there. It is, I have realized that like I like working remotely, but I don't necessarily like being forced to work at home all the time. So I'm hoping the hybrid flexibility is going to be a nice thing. I mean, my company currently is fully remote, so that'll be nice in the future. We can actually still like go around and do stuff.
I know the feeling. There's like pros and cons of both being remote and being at the office. You know, I miss all my coworkers.
Yeah.
But it's nice to be able to get to the office in 5 minutes. So.
Yeah, for sure.
All right. I'm looking forward to your talk. Let's. Why don't you take it away?
Awesome. Great. Let me share my screen.
All right. Here it goes. All right. Yeah.
Awesome. Cool. Here we go. Okay. So if anybody wants to follow along, I'm going to be showing a lot of code. I'll have a few slides, but then it's mostly going to be a code thing. You can grab this GitHub link now, and if you just like search for me on GitHub, it's one of my pinned repositories, so you can grab that and take a look. Otherwise, just follow along now. So we kind of already went through intros, but if you want to find me on Twitter, it's all the way there at the bottom. Basically, all my stuff on the internet is those 6 letters, RIKTURR. So Twitter's there, and if you kind of want to add me somewhere, I'm definitely happy to take questions. Go ahead and post them in the chat, and I'll try to get to them towards the end. But if you do have more later that you think of, feel free to reach out. So I'm currently a senior data scientist at Saturn Cloud, but like I said, a lot of my work has been in like kind of large scale data processing, machine learning type stuff. So as far as who Saturn Cloud is, we're going to focus really on the open source Dask thing. But just to mention kind of who my employer is we're basically a platform for Python data science, like data science teams that use Python can kind of come on, use this kind of cloud-based environment to kind of do all of their work and then set up deployments and serve dashboards and all those things. And you're going to see the platform because I actually obviously do my day-to-day work inside of the platform. And we host like a Jupyter Lab kind of install, so then you can run notebooks and stuff. So the notebooks I'm going to show you are running within Saturn Cloud, just so you're aware. But Dask is the fully open source. All the stuff I'm showing you, you can run on your laptop or any kind of other cloud environment that you so choose. Okay, so into Dask, main point of today's talk. So the main core idea of Dask is that it's a parallel computing library for Python. And it's not only for Python, it's actually completely 100% built in Python. And so I think that's the differentiator that you see from some other kind of distributed or parallel computing libraries that might have been written in other languages that have APIs in Python. Dask itself is fully 100% Python. Like you can go to the GitHub page for Dask, and I'm pretty sure it's like 99.8% Python, and the rest of it is like HTML or something for documentation. So as far as like what Dask does, and I probably should start from the bottom of this list actually, and then go up. But it's actually a very, very flexible parallel computing platform. So it's not like you just have an API for certain types of data structures or objects that you would want to parallelize. It's not really rigid like that. There are APIs like that, but you can actually take kind of any arbitrary code that you have and then send it to run on a cluster in a distributed environment. And I'll show you that. I'll try to show you probably most of these APIs today, just so you can get a good idea. But a lot of the stuff that I'm going to be in these slides are going to be taken from the Dask docs page, Dask's website. Dask, I think, actually has some of the best documentation I've seen as far as open source projects. Very comprehensive. There's a lot to take in, so it can be a little bit overwhelming, but it is very comprehensive. So it's a great place and a good resource to kind of look through and then kind of get going on it. So basically, you can start from a low level, parallelize just really individual functions, and then there are higher level APIs within the kind of Dask core project that allow you to kind of work with objects in the same way that you would in like a single threaded manner, except it gets parallelized across either the cores on your laptop or across a cluster of machines. So those are things like arrays that you would do with NumPy, data frames that you would do with pandas, or even machine learning that you might do with scikit-learn. But What's also cool about it is that there's an entire rich ecosystem of packages built on top of Dask because of its flexible interface, that there's potentially some Python packages that will do parallelism under the hood using Dask, and you might not even know that Dask is kind of there. So as far as like what the arrays and data frames look like, if anybody here is familiar with using NumPy or Pandas, what Dask does is basically wraps around those projects. So it doesn't kind of reinvent the wheel or anything. And the APIs, and there's pretty close API parity. It's not going to be 100% because some things that you would do just aren't possible in a distributed environment, or just like very difficult in a distributed environment. And there might be like more parameters and different things that you would need to tweak. But the core concept is that a Dask array parallelized across a cluster is just a collection of NumPy arrays. And so Dask is handling the orchestration between all those different chunks of NumPy arrays, but all of those don't necessarily have to be in memory at the same time. And that's really where it's powerful. So you can do it on your laptop with a data set that might not actually even fit into RAM, or you could do it on a cluster to just take advantage of a lot more processing, a lot more resources to just do things faster. So same idea with the Pandas, Dask data frame. A Dask data frame is a collection of Pandas data frames. And here's where this kind of low-level API comes in. So there's this thing called Dask delayed, and you can wrap any just arbitrary function in Dask delayed. And this is now something that gets executed. That basically what Dask does is build up a task graph of what you're building up, like the different computation steps that you're doing. And then it'll kind of keep track of that DAG. And then when you're ready for a result, you can ask it to do this compute right here that you see on the fourth line. And then it's going to go across, optimize your DAG, figure out where it needs to pull data from, shuffle things around, figure out how it can distribute things, and then give you back your answer. So that's kind of where a lot of the power comes in. This is the core level of Dask. And a lot of what powers it is this concept of lazy evaluation of when you call a function, it doesn't actually execute immediately. But again, it gets added to this task graph, and then everything altogether gets executed. And Dask's scheduler figures out kind of the optimal way. Okay, this function can happen at the same time as this other function. This one has to wait for this other one, or this one can be skipped because you did some filtering or some weird thing later where it's actually not necessary. So it's very, very powerful. And I'll show you an example of this too later. And so this is just kind of what one of those task graphs might look like, where there's like a bunch of things executing in parallel. But a lot of the times you're not actually writing code for each one of these boxes. You're using a higher level API where under the hood this task graph is getting generated. Sorry, you can take that in for 1 second. I didn't mean to change it. So why would you want to use Dask, right? So coming from this meetup, I hopefully I've convinced you from just the point of being 100% kind of Python native, built for Python, built in Python. Other people who might be coming from other distributed computing platforms, say like something like Hadoop, MapReduce, or Spark. A lot of the points for why someone would want to use Dask is, again, that Python native thing, but also it's because of its ecosystem. It was kind of born out of the kind of ecosystem of Python data science packages. It was actually created at Anaconda as like open source, and obviously Anaconda funded it at its initial start. And so it's kind of already built in, hooked in. It has that kind of Python culture in it already, and so that kind of reflects into the later years as the project continues to mature. And it's very, very easy to scale. Like you can just pip install it on your laptop, and then now you can run code across all the cores on your laptop. And then that same exact code, you can then run that on a cluster of machines somewhere in the cloud. Some other reasons is just to show the popularity. These numbers are probably outdated now. This is like a year ago. Again, this is taken from a presentation that one of the Dask open source maintainers did. It's pretty interesting to see that 5% of all Python developers, so not just people who do data, actually use Dask, which is pretty significant if you compare that to 13% for Apache Spark, which is a very popular distributed computing platform. And I will say too that it's a really interesting point in Dask's life right now that there's several companies, like commercial companies, Saturn Cloud being one of them, that are very invested and interested in supporting it, and then taking it more to this kind of enterprise support level, where for a few years it was always this kind of open source thing that was used in academia, or there wasn't really any companies backing it. Now there's maybe 2 or 3 or even a handful of companies that are really invested in Dask, pouring in resources and money into the project, and a lot of people are really starting to use it now. So it's an exciting time to be using Dask as well. If you want to get started, you can finish watching my talk, but an even better place to be, if you just want to stop listening to me now and then do it yourself, is to just go to, again, Dask's open source resources are really good. They have a series of YouTube videos that'll get you from zero to just understanding what Dask is about, how the different APIs work, probably in like an hour. And then they have a tutorial on GitHub where you can kind of run through each of the different pieces really in depth, kind of at your own pace. And this tutorial is very good. And then, like I mentioned already, the docs. So I've already talked about this stuff already, but the key concepts to remember as I'm going to show you the code now is that Dask is building up a task graph, and it's this concept of lazy execution where it's not actually executing everything that you tell it to right away. It's only doing it when you kind of ask for results. And then the other main point is that these parallel objects like NumPy arrays or pandas data frames, Dask arrays and Dask data frames are just collections of those other, quote, normal objects under the hood. And so that's it as far as the slides. I'm going to go ahead and just jump into the code now. I'm going to take a quick peek to see if there are any questions. Nope. Okay. Go ahead, and if you have any questions just so far on the slide, go ahead and put them in the comments. I'll get to them at the end, and I'll remind you again before I'm close to being done, so that way we can make sure those questions are coming through. So I'm going to start off in Saturn Cloud. If you want to actually just like try Saturn, you just go to saturncloud.io, and we have a kind of a free plan where you get a few hours per month, just always free, and then you can kind of upgrade to like a pay it per use type situation. But mainly what I want to show you, I'm not really going to tour the product, so that's not what this is about, is I'm running here this kind of Jupyter server that has 16 gigs of RAM and 2 cores. So we support like much bigger machines up to like 500 gigs of RAM, but I'm trying to emulate like a laptop type sized machine just for this example, so I can kind of show you what's going on. But then also I've attached here a Dask cluster. So this is now a cluster of 10 different workers that each have 64 gigs of RAM. So that's like a much bigger set of compute resources that kind of have access to. So I'll just jump into the Jupyter Lab now. Okay. Oh, actually, you know what? I had a different window open. That was already configured. Okay, this is better. All right, so this is the repo that I showed you. Again, you can go ahead and clone this. There's an environment.yaml file if you kind of want to run this on your laptop. You can probably run the first and second notebooks. Actually, you know what? The first 3 notebooks, you should be able to run them with this environment.yaml file. You go ahead and create a conda environment. These are all the packages that you would need. The last one is running specifically in Saturn Cloud, but you can pop that out for any sort of other type of cluster kind of infrastructure. Dask supports probably like 10 different ways of actually launching a cluster of machines and then working with it. What I want to at least get across in this talk mostly is, again, the code that you're writing inside of Dask is going to work on any of those things. So you can start using Dask on your laptop, and that's really the best place to do it. And then it's kind of like a whole nother jump to kind of get used to the whole like distributed separate cluster that's running in a different place. And that's kind of why there's companies now around that, Saturn Cloud being one of them, that try to kind of make that easier for people. So as far as, it keeps going over here. As far as like what we're looking at today, it's just this classic data set that people always like to use for large data is this New York City taxi trip data. So basically it's just like a bunch of files on S3 that are public, but you'll get a bunch of CSV files, like 1 per month. And each of those files contains, each record in that CSV file is a single taxi ride that was taken in New York City. So in this case, I'm just grabbing the data from 2019. So there's going to be 12 different files, and then downloading them to kind of whatever machine that you're running on. So what I'm going to do is I'm going to basically try to take you from running something like quote on your laptop, and then show you kind of what code changes are need to be done to kind of put them into Dask. So I'm not really going to run these. I have the output saved in the notebooks already, but you can definitely run this yourself. I just ran these all earlier today, but I just don't want to spend the time to do that. So I'm going to breeze through this first notebook, but basically I'm showing you just some kind of analysis pipeline that you might do, kind of with this data all the way down to like training a machine learning model. So then I can show you again what changes when you need to parallelize it. So we're gonna, load some CSV files, and this is what our data looks like. Like I said, each row is an individual taxi ride, so you get a pickup date, and a bunch of other information. What we're gonna do is we're gonna try to train a machine learning model that can predict this amount, so like how much the ride costs, based on information that you would only have at the beginning of the ride, right? So like the pickup time, how many passengers, even the trip distance, because you're going to hop in the taxi and say, hey, take me over here. And then we're going to see if we can train a regression model that can predict the total amount. The model's not going to be very good, but the exercise is to show you how the code works. This is just kind of some exploratory analysis that you might do with pandas to kind of get some information about all the columns. And then here's where we're creating those features. So I'm just basically mostly is extracting information out of the timestamp column. So like, what day of the week is it? What hour is it? What minute is it? So hopefully that information, like at rush hour, maybe rides are more expensive and that kind of stuff. And so now this is what our data set looks like after that with those extra columns. And then here's where we're kind of doing our machine learning. So I'm going to import scikit-learn to kind of split up the data, and we'll split into a train and a test set, and then train kind of an XGBoost model. So just, again, I'm breezing through this really fast because mostly I want to show you is what the differences are between the Panda, like the single core code versus the Dask code. But then down here, we're training a model that can now predict this kind of total amount based on these other features that we have in the data. And then we kind of get that, right? So if you notice all the way at the top here, I loaded just the first CSV file. So out of the 12, right, I showed you that there were 12 files that total amounted to about 8 gigs. This all works perfectly fine. You can run this notebook yourself. It's all great. That's because in memory, this data frame takes about 1.5 gigs inside of RAM. But if you remember, actually, let me just show you. I know I'm not running this. I probably should have run it. But this machine itself, if I run htop, has like 16 gigs of RAM, right? So what ends up happening for Pandas is you tend to need 3 or 10 times the amount of memory as what the size of your data is to be able to like kind of like do a lot of processing. So as we go through and run these cells, most of this memory will then be taken. But the problem is that this is only 1/12 of my data. Like if I wanted to actually process on a larger amount of data, I'm kind of stuck because I can't even load the full data frame in memory. So if you scroll all the way down here, this is kind of where I actually tried to load all of the data into memory, but it's not going to work. So if you really only have 16 gigs on your laptop and you try to run this, it might actually blow up your kernel. If you have more, it might work, but it will probably take forever. It'll take probably like 20 minutes to load the entire thing. So if you try to run this, you might have a bad time. So just a warning. And then you might feel like this. So that's kind of why I'm trying to show you that Dask is something that might be useful. Okay, so again, that's like the typical kind of like data science exercise that somebody might do like on their laptop with the kind of traditional packages like Pandas and NumPy and scikit-learn. Here's what it would look like when you do Dask. And if I can show it to you side by side, you'll see that a lot of the code doesn't really change. The first thing that you would want to do is set up this client. So this is basically how Dask connects to a cluster. So when it connects to a cluster, it could actually just be the different cores on your own machine. So this notebook is actually something that you could run on your laptop even if you don't have actual multiple computers kind of hooked up. But it creates this kind of local cluster is what it's called. And so now it knows that it has 2 different workers, but I have total like 16 gigs of memory. So I can go ahead and run that. And you'll see like, this loading data part can almost be exactly the same. So what I'm going to do is I'm going to show you kind of 2 different ways that you might actually load these CSVs, just to illustrate the kind of low-level API that I talked about in the slides. So here are some Dask inputs. So I'm going to import this delayed function, which is what I showed you about kind of doing that low-level work. So if you think about it, if I wanted to load all 12 files, what I could do is just basically call that loading function on all the different 12 files, but in a lazy manner. So basically, I'm telling Dask to orchestrate. This is what the full kind of graph that I want you to execute. Go grab these 12 CSV files, but it's not actually going to do it right away. But then what you can do is you can collect them together into now a logical data frame that comes from those 12 different files, but then you work with it in the same API that you would with just like a single like a data frame from pandas. So I'm not going to run this one, but this is basically, again, what you would do. So, for each file in my data, I can now wrap this Dask delayed function around my load CSV function, which is, again, just calling pandas. And then I collect now a list of those. Again, this doesn't actually do anything, right? Do you see how this only took 15 seconds to run? It's because of this, again, this concept of lazy evaluation. And so this last line here is basically just saying, create a Dask data frame from this list of pandas data frames. So Dask will now let you operate with that as if it was a regular data frame. And then so you can see like these kind of different delayed things. You're not actually getting a pandas data frame, you're just getting a delayed function which hasn't run yet, but then it's kind of queuing up to the cluster to run it. So you could grab one of those, call this compute function, which is actually telling Dask, okay, go ahead and execute this, now give it back to me. So that's where you see it kind of takes a few seconds to actually pull the data down from S3 and then read it in. So this is kind of like when you would print out the data frame, you're not actually getting any data, again, because of this concept of lazy evaluation. Dask doesn't actually hasn't actually loaded any of the data into memory. So that's just kind of a way that you would do it, again, using the lower level delayed interface. But Dask, again, has its own data frame API that matches pandas. So if you notice, I can just call DD, which is Dask data frame, read CSV in a very similar manner as I did with pandas before. And then now, oops, I didn't run any of this. I didn't run my imports. You can see, again, this executes and returns. Oh, I didn't download the data. OK, sorry. I'm just going to pretend that ran. I don't have any data on this machine because I had to switch to a different one. But again, the outputs are here, so I can show you what's going on. This first cell wouldn't actually do anything until you ask it for some information. So if you tell me, OK, what's the length of my data frame? Now this took some time because Dask had to go collect those 12 data frames, compute the length of them all individually, and then aggregate that back and give you the full kind of length of all the different pieces. And because I'm only operating on a machine that has 16 gigs of memory, this machine actually will not be able to load all of the files at the same time. But what Dask does is it'll pull one file into memory, compute the length, and then kick that one out, pull the next one in, or it'll pull as many as it can. It'll probably do like 3 or 4 at a time based on how much RAM you have. But of course, if you give it more RAM, Dask will be able to do them all at the same time, and then it'll be a lot faster. But then again, all the rest of the computations are pretty much exactly the same as they were before. I can call describe on my data frame, except now I need to call compute on it because I need to tell Dask to actually give me back the answer. And then the rest of this code is actually exactly the same as what I showed you before. All of these data frame functions work the same way. You can call .head on it to get the preview of the data, works the same way. Dask even has a Dask ML library, which has a lot of the same classes that scikit-learn has. So you can do your regular train, test, split, and your metrics. And then the XGBoost package has a Dask submodule that'll let you do kind of Dask parallelized XGBoost training. So all I had to do was pretty much just change these imports, and then the rest of the code, again, is like exactly the same. So now I'm just calling fit on my XGBoost, and then kind of running that. So if you were to pull this notebook, run it on your laptop, it would probably be pretty slow because, again, there might not be enough RAM to actually load in all of this data. But the thing is that it's actually possible now, whereas before it wasn't even possible with typical pandas, NumPy kind of scikit-learn because you just couldn't even load the data into memory, right? So that's why I'm saying like Dask on your laptop is a great thing because you can continue to use similar APIs and then take advantage of parallelism and not really have to think a lot about parallelism. And then when you kind of need to scale to like even larger data sizes or you're just kind of impatient and don't want to wait for stuff, that's when you can kind of move over to a cluster and really like get cranking with a lot of resources. That's what I'm going to show you here. So this third notebook is the code, again, for doing stuff is going to be exactly the same as this other Dask notebook. The only difference now is that my client object is initialized a little bit differently. So if you look at this notebook all the way at the top, my Dask client was just kind of initialized without any arguments. By default, that means create a cluster with whatever my local resources are here. But then if I go into using a cluster, in this case, we're using Saturn which is kind of this platform, the company that I work for, there's all kinds of other different ways. If you have kind of an existing like Yarn cluster, or you have access to some kind of like Kubernetes resources, or even like Slurm or any sort of HPC environment, Dask supports all of those kind of cluster deployments, and there's a lot of different ways to do that. But in this case, I'm going to be doing it with a Saturn cluster. I'm asking for 10 workers. But then this client object works the same way as the other client object. Dask kind of abstracts away. It doesn't really care what this part is. It just knows that it can send work now through this client. So I'm going to run this. And then the rest of this code now, again, is exactly the same. So I'm going to just load up my data. But now it's a lot faster. And you'll notice, actually, also when it gets down to this, Dask has this Jupyter Lab extension, which actually I think I need to put in my new dashboard link. But there's this Jupyter Lab extension where Dask will actually kind of like hook up to your cluster, and you can kind of watch it processing and doing things. Let me see. Okay, go pick that up. All right, let me execute this length again. Sometimes you got to refresh these little pages. Okay, so again, this first command didn't really do anything. But now when I call length is when Dask is actually going to go ahead and process things. So you see now how it tells you actually what individual functions it's running, which is really awesome for debugging purposes. So you can see that it's running read CSV on with like a bunch of different chunks. And then here, this task stream, each kind of horizontal bar is a single processor or CPU and or core. And then you can see that like a bunch of things are executing in parallel. Let me run something a little bit more intensive that's going to light up these charts a little bit more. In this case, I want to compute the actual memory usage of the entire data frame. And let me open up this map again. This one is pretty cool. So this cluster map here, this widget is actually showing you all the communications that are happening between all of the different nodes in the cluster. So in this case, when I'm doing this memory usage, it has to do a lot of data shuffling because it has to compute like, min, max, and quantiles, and like all this different stuff. I don't actually really know what it's doing. But it actually has to send a lot of data. And so let me run this again because I think it's cool. And so now it'll actually show you this center one is the Dask scheduler. But then here now you're seeing that data is kind of just being shuffled across all the different workers. So it's kind of just like mesmerizing and fun to watch this as you do stuff. But now, if you were to run this other notebook, I think I kept my runtimes in there. But yeah, this length call itself took 2 minutes, like on like a laptop size machine with 16 gigs of RAM, again, because it couldn't load everything in the memory, had to kick stuff out. But in this case, the cluster is big enough where it can actually process all the different CSV files at the same time. Only took 15 seconds. So let's go ahead and run the feature engineering stuff. Again, this is all the same stuff. And then what Dask also now allows you to do is there's this concept of persisting. So because of this lazy evaluation, again, Dask doesn't keep the stuff in memory. It'll go and grab the CSV files because that's your full task graph. But then the problem is if you're doing something like training a machine learning model, you're going to need to re-reference that data constantly, like all the time. So you can do this thing called persist, which essentially checkpoints the graph. So it'll execute everything that's in your graph, and then it'll hold it into memory, except now across the cluster. So you'll see now that it's calling this read CSV stuff. So it's loading all the CSV files again in parallel, and then storing it into memory across the cluster. And we'll kind of let that happen. I don't know what's going on with this map. It keeps thinking it's sending data to this one worker. Okay, so now actually if I run this length, it's like even faster. Now that only took 149 milliseconds because Dask didn't actually have to go reach out and grab the files again. It had the data already sitting in memory, just needed to call length on those objects. So if we go back up, you can see that before, that still took 13 seconds. Right. Okay. So now we can get down to doing our machine learning stuff. And so it's a little anticlimactic because all I got to do is run cells where the code looks kind of exactly the same as I showed you before. But hopefully I can hand wave enough to tell you that like this model is training across all these different nodes on the cluster. And because it's using XGBoost, you don't get a lot of the fun little progress items because basically XGBoost is doing all the work, but it's taking advantage of Dask to do the orchestration across the different workers. So the XGBoost module actually has already built-in ways to kind of do distributed training. It just hooks into Dask because Dask is kind of this generic cluster interface where you might be using other libraries that also take advantage of it So it's just a really nice, clean way to have like a consistent parallel computing interface. And then there you go. I just trained my whole model in 26 seconds. I think, let's see how much data we had. We had 84 million rows, and then I just trained an XGBoost model in a few seconds. So that's pretty much all I have in the code. Again, just to jog your memory, if there's any questions, go ahead and dump them in. I do have a couple more slides to show after this, but this is a great time for you to kind of think through or what any kind of questions you have. And I see there's some in there, and I'll get to those at the end. But that's like a really, really quick, fast intro to Dask. Like I said, go ahead and grab this repo, check out the Dask tutorial, and you'll really be able to see a lot of this stuff. There's a lot, like I showed you mostly the higher level APIs, but this low level Dask related API I use consistently a lot, and it's really, really powerful. So I would really encourage you to check in that and try to get that working. Okay, so I told you about this thing where it's like Dask is a great experience on your laptop, and this is one of those things where like you should use the tool that you kind of need at the time, right? Like don't go for Dask on a cluster if you only have like 100 megabytes of data and it fits comfortably in pandas and you're never waiting too long. Like totally stay in that world. It's still much better because a lot more of pandas has a lot more than what Dask has implemented, right? Because Dask has to go through and implement all of this stuff into like a distributed paradigm. And there's actually a question about this, and I think it's relevant now. There's a question, is like, can you kind of like fully replace pandas? Like if I imported like Dask data frame as PD and then would everything work? No, probably not. But because again, Dask has to go through and kind of re-implement a lot of those things. There's a cool package actually called Modin. I don't talk about it here, MODIN. But their goal is to be that fully drop-in, like import Modin as PD. And what Modin does actually uses Dask. It has a couple different kind of like back-end parallel computing engines that it can use. Dask is one of those. So if you kind of want that drop-in replacement, you can do that. I don't think it's 100% there, and it's probably going to take some time for that. But that's definitely something to kind of check out. But again, is you kind of want to take these steps. Start in the regular tools. If you really need some parallelism, try Dask on your laptop. If that's still really slow, then go for the kind of like the cloud. And again, Dask works really well on a single machine. So you could just go get a machine with 500 gigs of RAM and then use Dask in that local cluster environment. And a lot of the times that's better and kind of favorable because you're not having to deal with multiple different computers. You're not waiting for network IO and kind of all that stuff. Modin is the package, MODIN. So I talked about this kind of, there's a lot of details about running Dask kind of on a cluster. I'm not going to go through all of those. I think a really easy solution, like I said, it's the company I work for, Saturn Cloud. You can kind of just go in there and launch up a cluster. And I think this is my last slide, so go ahead and put in your questions if you have some. But what's cool about Dask too, it's just like a great open source community. So you can totally contribute to it. Again, it's 100% Python. So if you're somebody who's really kind of a Python user, some other libraries might be a little bit difficult because I always had a hard time because I wasn't really able, or it felt a little daunting for me to contribute to Spark because most of its stuff was written in Scala. It just had a Python API. So if I had a bug and I was trying to fix it, I would hit a wall because I'm like, oh, I got to go over to the Scala. I can't do that. But with Dask, I can go in there, look at the Python, kind of run it all on my computer, and it's kind of easier for me. Okay, well, so that's most of the talk. There's a few questions in the chat that I can start to address now. But again, if there's any more, feel free to kind of dump those in. So let's see. So I kind of addressed some of those Dask and Pandas kinds of questions. Somebody asked if this is a replacement for Spark, for PySpark. I would say it depends. It depends on how you're using Spark. So in my kind of past life, I use Spark for a lot of kind of like big data, like data engineering type workloads. And I think it's a really good platform for that. Personally, I don't think it's great for machine learning. And because of the kind of MapReduce style like paradigm that Spark uses, it's not really good at parallelizing like arbitrary functions the way Dask is. And it's really not great at doing machine learning, multidimensional arrays, a lot of this more advanced like scientific data science-y type things. I think Dask is a better tool for that. So again, you probably could replace many PySpark workloads with Dask. But should you do that? Again, it depends on kind of what you're doing. Speed-wise, I have done some benchmarks speed-wise between Spark and Dask. I would say a lot of things are similar. Sometimes Spark is faster. I would say that probably, again, this is just kind of my own intuition, like the SQL type work, very just like data frame joining and like that kind of work. I could see Spark having an edge over Dask on that. But then Dask has a lot more on the kind of, again, like machine learning side, advanced computing, scientific computing stuff. And I didn't mention it in this talk actually, but it has a pretty good deep integration with a package called Rapids, which is for GPU accelerated kind of data science work. Basically everything that I showed you here, there's another level where you can do it on a GPU and then you can do it on a cluster of GPUs using the Rapid packages. And those are gonna kind of blow out any sort of kind of CPU oriented work. So in that case, it would be a lot faster.
So
yeah.
We have a question. How do you import, or can you import Dask? Like, how much of a replacement is Dask for Pandas? Like, can you just import it and start using it, or is there some caveats?
Yeah, it's not going to be like, it's not going to work if you just completely do just like switching out the import, because again, Dask has to do things in a distributed manner. Sometimes you have to give Dask a little bit more information about what you want to do, but the core API is the same. So like that read CSV, the way that you add new columns, the way that you're indexing and this and that, all that feels the same, but you might run into a couple of things where, oh, I can't do like assignment with .lock because of the nature of the distribute thing. Or when I want to run an apply, I have to give Dask a little bit more information about my metadata. So there's different things like that that would come up. So you might get lucky and it might work if you swap the imports, but you're probably going to have to tweak a couple things.
And I guess, I know you kind of touched on this, but can I, like, we have a question, can I self-host Dask?
Yeah, totally. You definitely can. So like even if you had like a closet full of computers, it's really easy to kind of hook those things up. You could basically the core of Dask is running a scheduler process and then a bunch of worker processes. So as long as those can communicate over a network, you can fire up a scheduler process on one computer and then fire up the workers on other computers. Dask also, the open source package, has ways to hook up into your cloud providers. So I think like AWS, Azure, and GCP, you can kind of self-host Dask that way to where it'll just launch a cluster using those cloud services without using kind of anything else on top of it. So yeah, there's a lot of different ways. Dask is very flexible in that perspective.
So I have a question or two.
Sure.
When you define your own custom like environments, is the platform responsible for shipping like your dependencies and your code all around to the different workers, or does Dask have some tooling to support that?
Yeah, that's a great question actually. And so Dask is kind of expects your environments to be consistent across all of your workers. So there's ways for you. So let me answer first. The recommended way to do it is probably to use like Docker, right? So like you would want to fire up all of your workers with the same image, definitely the same version of Python. They all need to have the same version of Dask. And then any other packages you're using, you're probably going to want to have all the same version. So of course, Docker is kind of like the easiest solution from that perspective. And the way that you would launch a cluster with like those cloud providers is you would provide it an image, and then that image would get launched. Same with Saturn. We just provide some wrappers around making Docker a little bit easier. But yeah, so it does expect the versions to be consistent. As far as developing, there are ways that you can pass like a Python file or module to your workers. Like if you're tweaking your code like kind of live, Dask has ways for you to do that. But for when you're going to go run something in production, the best way is to make sure that everything's got the same image.
Cool. Let's see. I have one more question too, actually. How much flexibility do you have in defining like your own functions that run on the Dask? Are you like restricted to using kind of the built-ins to Dask and like its ecosystem, or can you kind of define functions and such that are arbitrary that run?
Yeah, you can totally define arbitrary functions. Like I can do it for you right now just because I think it's cool to see. So I can just say, I can wrap this delayed decorator across some function, right? And I can just say, return, this is a simple example, right? But now that's kind of something that's going to get executed now on my cluster. So if I would call this, you'll see that the result is not actually the result. But if I call .compute, it's now actually going to execute this thing really fast. It is actually executed on some worker in my cluster and then gave it back. So again, if you can kind of take that idea and kind of stretch it out, you can have a whole suite of all these different functions. And then Dask will kind of figure out how those all interact and then execute them on your cluster.
I have one more question. Does Dask have a UI, or are those UI components that you demo, are those part of Saturn, or does Dask have its own UI?
Yeah, this is all Dask. So actually, from the first client, if you click this dashboard link, this is kind of the original traditional dashboard where it's a separate thing. I tend to use this actually mostly because I just put it on a different monitor, so you can see a lot of these same graphs. But Dask also has a Jupyter Lab extension. So if you just look up Dask Jupyter Lab extension, that's where all of these widgets come from. Like we do a little bit in Saturn to make sure that they hook up to our cluster. But if you're using this on your own machine or your own cluster, you'll get all these widgets out of the box.
Very cool. I guess one last thing for you. Do you have any calls to action for the community?
Yeah. So I mean, I would say like, it's kind of generic, but I think it's good. Like continue to contribute and to continue to like be open and welcoming. I think is something that's really important for like a programming language and a community around that, because we want to make sure to kind of welcome as many different types of people as possible, because that makes kind of the community better. It makes the open source packages better, and I think it just continues again to make it something that Python's going to be here being used every day for the next 30 years. So I've seen it in other different kind of languages, really great communities, and I've just kind of encouraged all the people operating in Python to continue and carry that forward.
Well, thank you very much for if everyone could give a round of applause in the chat to Aaron. That was an excellent talk, and I learned something. I learned a lot of stuff about Dask.
Awesome. Well, I'm glad it helped. I can these slides I can make it available to everybody. Actually, the slides are in the GitHub. So if you go like to my GitHub repo at the beginning, the slides are right there, so you can kind of follow along and grab everything.
Great. Yeah. Thanks again, and yeah, thanks for the talk.
Thank you. Thanks for having me.
So we're going to take a few-minute break, and but stay tuned. We'll be right back for more and for another great talk, and we'll be back in about 3 minutes. Hey everyone, welcome back. We had one excellent talk, and we're about to have another great talk, or excellent talk. So I'm going to pull Andrew onto the stream. And hey, Andrew, can you hear me?
Yep, I can hear you.
Great. Thank you for joining us. Why don't you tell us a little bit about yourself?
Sure. Yeah, so Andrew Scott. Right now I'm a senior product manager at Palo Alto, and I'm also the co-founder of Ochrona Security, which is a Python-focused software composition analysis solution. So keeping your dependencies safe. But my background's really in development, a lot of stuff around developing security tooling, and even further back than that, there was a lot of automation, QA, that kind of stuff.
Cool. How did you find yourself like making your way to Python?
Really kind of by necessity. Starting out my career in QA, seeing the path forward being around development and wanting to build fun stuff. Python was a great way to get started, and it is kind of one of the go-tos for writing automation and testing frameworks.
Cool. And besides Python, what are your favorite languages?
Ooh, so I really enjoy Swift. I don't give it as much love anymore as I used to. Don't have as much time for it, but I do enjoy poking around Swift. Yeah, I'd go with that.
That's a good pairing. Having a app development language plus like a server capable language.
Yeah, and it's finally in a good place now where it's not constantly being like rewritten almost every year. So I feel like you could actually make solid progress if you develop something in it these days.
Yeah. So obviously it's been a tough year. How have you been dealing with COVID and keeping busy?
Good question. So I was living in Chicago and then I moved out of the city, and that was my coping mechanism. I couldn't deal with the noisy neighbors at home all day. So yeah, moved out to the country.
Yeah, it's certainly nice to get away from the big city, and nice to be capable of like living somewhere where you have a little bit more space. It's awesome. Well, let's get started. I'm really excited to hear your talk. So maybe you can share your screen. We'll get you set up to go.
Yeah, let's do that. Okay, can you guys see my screen?
Yep. All right, take it away.
Sweet. So today we're going to be looking at the dangers of the Python standard library. So before we get into it, we should probably say what is the Python standard library for anyone who doesn't know. It's the batteries included modules that are shipped with Python to help developers accomplish common tasks. So you don't have to reinvent the wheel every time you guys are trying to do any kind of simple operations. And so there's built-in modules like OS for interacting with the operating system, CSV for working with CSV files, and there's quite a few of them in there. So these are all the baked-in things that you're pretty used to working with in Python. And so we want to look at the dangers here because just because something comes with it, obviously the language has been around for now like 30 years. There are still some gotchas lurking in there, so we want to make sure we can call those out. So the first one we'll look at is assert statements. So if you, like me, come from a testing background, you're probably pretty familiar with seeing asserts. They're a great way to kind of test the truthiness of a statement there, make sure your tests are working. And in tests, they make a lot of sense because if an assertion error is raised, typically the testing framework is going to be able to latch onto that and give you a nice message about what went wrong there. The problem with asserts is that you should never use them in production code because they're only executed if the dunder debug constant is true. So this might be something that you don't encounter frequently, but if you're ever writing code that's going to be run in an environment you don't have complete control over, you never want to use asserts, and you really shouldn't use them anyway. And the real danger here is that if you are doing some sort of truthiness check for an assert, and then the operator who's running the code can run it with debug turned off, and they can basically just skip over any of your assert statements. So what would this look like? So this is like a toy example. It's not super realistic, but let's just pretend here we've got a hard-coded password up there. We've got a function to log in, and inside that we've got a try except statement. And what we're going to do is just basically try to get some input from the user, try to assert whether that user inputted password matches your hard-coded password. If it does, we're going to welcome them. And if not, we're going to raise an assertion error and print out wrong password. So in normal operations, this would pretty much work. However, if you ran this with debug turned off, it would totally skip the assert check there and go straight to print welcome. So not what you want, especially from a security perspective. So solution here, just never use assert in production code. Use if else or other mechanisms. There's really no good compelling reason to have assertions in your production code. And just as a follow-up to that, you should try to write your checks, especially security-centric checks, in a fail-safe way, i.e. if something unexpected happens, don't allow access. So fail closed. Next, we'll look at string formatting. This is one it's kind of weird. Maybe one that we won't see too much in the future, but it is a fun one to call out just because it's a weird security case that I hadn't heard of. So the legacy format statement, like what you see here, is susceptible to data leakage if an attacker is able to modify the format string. So the format string's that part over there on the left side. You could call it the template. Basically, the string that you're going to be adding new data into is what we have there. And basically, the risk here is that if an attacker or adversary or whatever is able to create that string or modify that string, then you can be susceptible to leak internal implementation details. So what's that look like? So in this example here, we again have a hard-coded secret, which is just always a bad idea. So don't do that generally, but for these examples, that's how we're going to show it. We've got this hard-coded secret. We've got a class called animal that's just instantiating and setting a name variable. And then we have a subclass of that named bear, where we're not doing anything special. We're just naming the class bear. Then we have a print function down there just to print out the intro, and that's going to take a template and basically an animal object, and it's just going to print that out, that formatted string. And then we create an instance of bear named Mike. And so we can see if you pass in something relatively sane in there, we're basically referencing the name of the animal and the name of the class, we can print out something like, "Hi, Mike the bear." However, if you allow them to the user to modify what that looks like, where instead of accessing the dunder class, dunder name, if we look at dunder init, dunder globals, all of a sudden now we can print out the entire dictionary of all the objects we have for the program, which is going to be bad in this case. So what a more real world example will look like of this. This is semi-real world, a little bit more real than the last example. We could have just kind of a basic web server here. Again, another hard-coded secret, going to be a theme in the talk. And basically we'll just do a GET request to this. And then you can see there on the line below the function definition, we have a format string. We're basically going to just print out some HTML that has the location and the path that you're accessing here. So if I hop over to this example, I've got a little web server running here. We can refresh it. That's going to change. Great. And now I'm actually going to stop and share another window so we can show what an exploit of this could look like. And I'm only going to switch windows just because the browser does not like, browser is going to reformat our string here and not allow us to exploit this. So now you should be able to see my VS Code. If I basically run a command here where I'm going to that web server and then I'm passing in this kind of malicious string here, then it's going to print out location, and then it's going to dump all the internal variables there. We've got our secret in there. So that would be bad news if you had something like that hosted on an actual application. All right, go back to the slides. Okay, so what do we do about this? So the solution here is going to be just always avoid the ability for the user to impact the format string at all. Again, this is sort of a strange case and not one that I would really expect to commonly see. But if you do have a use case for this, just kind of rethink your use case. Second bullet point here, use F strings where possible. They're more secure, they're more readable, they're just better in almost all ways across the board. So if possible, use F strings if you do have to do something like this. And then finally, if you're stuck in a situation where you can't use F strings, you're using an old version of Python or something, try to do some sanitization of the input. This is always just a good security practice as well. Make sure you're sanitizing any input, doing validation checks on anything the user's input there. All right. So the next one is going to be for the tar file module in Python. This one's going to be the module used for working with tar archives. So being able to create new ones or extract the files within an archive. And the risk here is for arbitrary file write. And so the danger is that if you have an archive that has someone has tampered with, or someone's created like a poison archive that has a file that would extract to somewhere other than the target directory, then tar file just allows this to happen. So an example might be where you would have a tar file that then is trying to extract something out to like your home directory, or trying to write something out to overwrite like a host file, something like that. This would be allowed to happen. There's no checks that make sure that that it's not trying to extract something outside of the target directory. It is worth noting, however, that zip file, which is very, very similar, operates in many of the same ways, is actually not susceptible to this vulnerability. So I'm not going to share this, go through all this code. It's a little bit detailed, but basically this is how you would create a malicious archive. You're just creating an archive and then dropping in a file at whatever path you want there. So this is how you would create one of those. How would you protect against one of these is probably more important than how would you create one. So if your application accepts any user archives and then you try to extract them, you should always add safety checks. So there's examples online of how to do this, how to make sure that you're not going to extract something outside your target directory. Even easier than that, you can use like a safety wrapper class like tarsafe, which is actually a class that I wrote that is being suggested by some like security static code analysis tools as an alternative if you're using tarsafe in an unsafe way, or tar file in an unsafe way. And this is basically direct drop-in. You can use it in all the same ways as tar file. It's just going to have those basic safety checks baked in for you. Okay, next one is going to be XML parsing. So XML parsing, there's a few dangers to this one. Today we're going to look at specifically like the denial of service style billion laughs attack, but external entity expansion is also a risk for the default XML package. So we can see here, this would just be a very, very basic example of how you would start parsing XML, just using the E tree and element tree parts of the library there to parse XML. So if you haven't heard of a billion laughs attack, it is a denial of service style attack that leverages entity references in XML. So we can see in this, and this is basically like a payload here, that we've got an entity up there named lol, and then we've got a bunch of other entities below that that are all referencing lol and lol1 and lol2 and etc. And the end result of this is that if you actually try to go through and parse this, it's going to expand all those entities, and you're going to end up getting a billion instances of that lol there. So that would be bad news. It's going to consume a bunch of your resources, and it's going to take some time to run. So I'll jump in and demo this. So what this looks like. Okay, there we go. So you should now be able to see my window here. We've got basically a pretty simple little script here to generate that billion laughs attack payload. We've got our vulnerable version over here, just basically trying to parse that. And then we've got this kind of run here, which is just going to try to run this in a new Docker container. And then every second, we're going to print out the memory usage of that. So if I start running that, we can see some code there. It's going to start running. We can see immediately the memory usage is just going to, at the beginning, more than double. And it's just going to continue growing and growing until we exhaust all of the memory I've allocated to the Docker engine on my laptop, and then it's going to crash. So it's crashing now. That's why it's taking so long. Again, just another toy example, but if you imagine that you're trying to parse some XML on a web server that you're running, that's bad news if someone can knock off your web server just by sending you some bad XML. All right, get back to the slides. So what can you do about XML? Probably the easiest thing to do is just use a safe alternative, something like defused XML. It's going to work in almost the exact same way in almost all cases, and it's got all those safety checks built in. So it's either going to parse them in a safe way, or it's going to raise an exception so that you don't end up running into one of these use cases where you're pulling in dangerous data or suffering from some denial of service. All right, and the last one we're going to look at today is deserialization with the pickle library. So Python pickle is vulnerable to arbitrary code execution when you're loading untrusted data. This basically means that if you try to load a pickle that has malicious stuff in it, it can literally take any action that the current user has access to on your machine. So can access the OS module, can really do anything it wants on your machine. So very, very dangerous. So this is an example of what a bad pickle would look like. I'm not doing anything bad in here. I'm just creating a file, a text file as an example. But basically this dunder reduce method, anything that you put in there does get executed during the pickle loading. And so that's where you can sneak in all kinds of bad stuff. In the example here, I'm just, again, creating a text file there using OS system. I'm pickling that, so I'm pickling my instance of Picklebomb, and then I'm printing out the pickle just to kind of illustrate what this looks like. And this one, it's pretty easy to tell that there's something in there. Just among that hex, you can see the touch bad file. But if you imagine you try to do some kind of obfuscation techniques, base 64 encode some payload and drop it in there, that's going to be pretty tricky to parse out. And most people aren't printing and inspecting their pickles before they load them. If they see something online that sounds relevant to them, they're just kind of loading pickles. So what should you do about this? Basically, don't load untrusted pickles. It's just a really bad idea. I don't see people doing this too often, but I have encountered a handful of different popular open source libraries, especially in like the machine learning space, where they have methods to load pickle data. So if you're loading some target data from some untrusted source online, you would be susceptible to this kind of attack in many libraries. You could try to inspect the pickle object like we just saw. You could print out the pickle object. You could look at the code, but it gets pretty messy and it's going to probably be incomplete. And again, the attacker, if they're actually going to put any heart in this attack, they're probably going to do more to try to obfuscate that code. So really, the solutions, if you want to do something like this, is to consider an alternative like JSON for your serialization and deserialization. There's pros and cons on both sides, but stuff like JSON is a lot more portable. So if you're going between different languages, communicating between servers, or have to inspect anything as a human, JSON is going to be a lot easier for you to kind of grok what's going on there. All right, and that is what we've got. 15 minutes. Awesome.
Those are some really good tips. Like I'd never heard about the assert stuff. Like I usually don't put asserts in my code, but like I didn't know that it could literally be skipped if you turned off debugging.
Yeah. It looks like there's a couple questions over here I can probably tackle.
Yeah. So we have a question. Can you present an example of strings versus format? So like what makes, I guess, by extension to that question is like, what makes F strings more secure?
Yeah, so F strings are going to be more secure just because they're not. You're not going to allow the user to define the string itself. So there's no real format string that they can latch onto. And generally, the format one, more so than even using F strings, is just the advice to not ever allow the user to be able to modify that part of your code. Like, you can allow them to give you obviously the value to substitute in there, but there's really not many good use cases to allow them to have access to the format string.
So we have another question. Let's see, could you list the contents of the tar file to get the full paths of?
Yes, you absolutely can. I am blanking on the name of the method to do that right now, but it's documented. And if you are doing this by hand, that's how most of them are doing it. There's a few other things you want to check for when you're inspecting the contents, more than just like looking for like slashes. You want to look for like symlinks and other things like that too. There's a few other ways you could leverage an attack like that. So yeah, that tar safe library again is going to do all those checks for you. And I've also seen other code where they actually do those checks explicitly in the code.
So I have a question, like what maybe general advice and resources would you give to people who are developing apps for like how to like produce more secure code? Like,
yeah. So there's probably a few different ways you can go, and there's a lot of good open source tools out there. So one of them is going to be Bandit. Bandit is a static code analysis for Python. It's going to be able to catch a handful of these different things. So that's one I would definitely recommend. It's a pretty popular one, totally free, totally open source. Let's see, for other stuff, so like Ocrona, I'm going to pitch that one just because it's a project that I'm working on. That one's more for dependency analysis. So that's another big aspect of security you want to pay attention to. There's obviously so many libraries out there that are easy to pull in. A lot of those might not be maintained, or they could have vulnerabilities, or you could be pinned to an older version of the code. And so you always want to make sure that the dependencies you're pulling in are also safe. That's probably a good place to start, is some sort of very basic static code analysis and some kind of dependency analysis they're going to catch the bulk of errors.
I have a few more questions that just came in. Do you have a GitHub repo with examples?
Yes, yeah, I can share that out. There's also, I write about a lot of this stuff on Medium, so a lot of things in this talk, there's detailed articles about each one of these that go into more depth. Yeah, I'll share the slides out, and I can share my GitHub as well.
Great. And then we have a question. Is there a way to check for dangerous code inside of a pickle?
So there's definitely the opportunity for it, but just the level of freedom that an attacker would have to create a payload makes it pretty infeasible that you would have much success with this. So like we looked at in that example a couple slides ago, you can print out like the pickle data, or you can just view it, view that string there, and you're going to be able to pick out some words in there, but actually writing something to go through and inspect what's going on here. And there's actually, I'm blanking on the write-up I've done about this. There's another class, or there's another module that's available to do pickle inspection, but it still makes it very, very difficult to actually be able to tell with much confidence whether something good or bad is going on there.
I see. Very good questions. So I guess one last question for you is, do you have any calls to action for the Python community?
Yeah, just be aware. I think security is I'm going to pitch about security because it's what I do as a hobby and professionally. Just be aware that these kind of incidents are on the rise, and so it's relatively easy to take small steps to improve the security of your code. Obviously, some little things like this, a handful of free tools, and you can be miles above where you would be without those kind of things. So yeah, I would just recommend folks protect themselves and be aware of these things.
Great. Yeah, that's awesome advice. Thank you very much for your talk, and I learned a lot from it.
Thanks.
All right, so we are reaching the end of Chippy. So we had two excellent talks, and thank you again to our sponsor JFrog. If you want to sign up for that raffle, you still have an opportunity to scan this QR code or go to the link I sent earlier in the chat. Yeah, thank you for our speakers. If you want to stay attuned to future Chippy talks, which we have quite frequently, at least once a month, feel free to subscribe below. The fun isn't over though. We have more. We have more stuff at we have a after party planned at our Chippy.town gathering. So if you're not familiar, I mentioned before, it's like a little space where we can get together and just chat with all of your friends. So thanks again for joining us, and hope to see you at Chippy.town, or if not there, at least next time on the stream.